Alright, let's compare f of x graphs to f dash graphs. Let's see what they look like, right? So I'm going to put, at the top, I'm going to put the original graph, the function, and at the bottom, I'm going to put the exact derivative function of that graph. So we can sort of see how they work together. And what's important about these is the x-intercepts. Okay. So this is going to be function and derivative functions. So on top here, I'm going to have f of x, but at the bottom here, I've got the exact derivative of this function over here. That's my x, and that's my x, and my x as well. Alright, so now from here, I go up like that, I go down like that, I go down like that. Let's just say the function did something like that. I want to sketch the derivative of this function. The first thing I need to note is the following, which is the turning points. Those turning points over there, I'm going to draw a line straight through it, and there's another turning point over there, I'm going to draw a line straight through it over there. Those turning points have a derivative equal to 0. That turning point over there has a slope of 0, and that one would be right on there, right? So we're saying that at that point, the derivative will equal 0, right? Which is this function here, will go all the way down. So those 2 points are very important. Another thing we notice is that the slope is positive up to that point, and then it's negative after that. And it's also negative before it gets to this first minimum, before it goes positive again. Negative here implies everything on this side, and positive here implies everything on this side, because that's the positive gradient. That's the negative gradient, and so it's negative. This would be negative on this side as well. So those are the regions that the gradient should lie in, or the gradient function should lie in. So when we sketch this function, we know it has to pass through these 2 points, it has to go through this region, and it has to end up in this region and this region, which means you can see the parabola forming for this function. And so that would be a sketch of my gradient function. It's got to turn somewhere. It can turn anywhere. It can turn anywhere, actually, as long as it goes through those points of the bit. Now, the turning point could also be at the point of inflection, at that point where the gradient is going from increasing at a positive rate and decreasing at a positive rate. So it's sort of going steeper and then less steeper. At the point where it changes its steepness, that can be in line with the turning point, because that's where the gradient goes from, even though it's positive, it's an increasing positive, but then a decreasing positive as it approaches 0, which is my turning point. So maybe I could include that in this function and say, okay, well, if that's the case, then let's draw another line. Let's draw another line that would run through that point of inflection. That point of inflection, which is, let's say, okay. And now I got to ensure that my line turns at that point. Something like that. Alright, and then I've sketched my function, giving all the different points that I need. Alright, let's do another one. Alright, so my next function looks like this. Okay. So firstly, what I want to do is sketch each part. away, minus away. That's going to be a turning point. There's another turning point just over there. We've also got these points at which the concavity of the graph changes. So your double derivative will be 0. The second derivative gets you your concavity for those lines there. Okay, so that's all the different parts there. Now, where it turns is where it cuts the the x-axis. Where it turns is where it cuts the x-axis. Where it turns, cuts the x-axis here. And this is also, by the way, negative, which means we're going to utilize the region at the bottom first, the negative region. Alright, it's negative up till that point there, and then it's positive between those 2 points over there. So it's going to be in the positive region over there, before it's negative again over here, before it's positive again over here. Alright, so those are the regions that I need to have. And also try my best to make it turn on this line and turn on this line. So it's going to go like this. Covering all the different regions over there. And this is, by the way, the gradient function of the original function.